Hello everyone, today we're going to talk about aquifers and then specifically our own local Edwards Aquifer. So first, our definition of an aquifer. An aquifer is going to be a body of rock, sediment, or soil that contains drinkable water and can transmit or carry this water to wells or springs in economically usable quantities. A few key words there. It's got to be a usable quantity. We have three main types of aquifers. There's an unconfined aquifer. This one's the most common. Confined aquifers, and then the karst, which is the most uncommon. Karst is a special type that occurs in limestone rocks when a system of caves are connected and water is flowing through it. We're going to spend a lot of time today talking about the karst aquifer because that is the type that is our Edwards Aquifer. So let's look at the other two first. So the unconfined aquifers are again the most common. In this case, water seeps through porous materials near the surface. So things like soil, gravel, but then are trapped by impermeable rock below. One of the largest aquifers in the United States, the Ogallala Aquifer, is an unconfined aquifer, and that provides water for most of the central United States. A confined aquifer is going to have impermeable rock both above and below. In this case, we need to have the layers of our earth. The rock strata must be able to bend so that there's an outcrop, an area of opening between our two rock layers for rainwater to enter into, recharge, or refill this porous material in between. So in this image here, we have our confined aquifer, and then these would be this zone of saturation. That would be an unconfined aquifer. And then the third type is the karst. This develops in thick limestone formations, forms when slightly acidic rainwater dissolves limestone. Limestone is slightly basic. If you put drops of vinegar on limestone, it will start to bubble, not boil, excuse me, bubble. This is our most uncommon type, but this type is very important to San Antonio residents because this is our Edwards Aquifer. And so with all this percolation, we get lots of little caves. Some of the caves that you can go and visit include the Natural Ridge Caverns out I-35. There's others near Austin, Rock Springs, and Kickapoo Caverns, which are a state park near Brackettville. So water is able to get into this system so it can soak in through the soil. There's also sinkholes, which will lead directly into caves, providing for large influxes of water. So here we have, in this image, we can see a river. Sometimes those or small creek falls right in. We've got sinkholes. Apparently, the Edwards Aquifer Authority, when they've come in to talk to us before, they've talked about how they have had to help pull vehicles and cattle out of sinkholes. When we look at our aquifer is divided into three areas, and we'll see these three areas actually with any type of aquifer. There's a drainage zone, a recharge zone, and an artesian zone. And so our campus is located up here right at the edge of the recharge zone. And so here's another view showing some elevation. The drainage area is a higher elevation, right? This is way up here, Bernie, Kerrville, what we refer to as the hill country, right? A higher elevation. Recharge zone is going to be where most of those sinkholes are, where any water that soaks into the ground is going to end up in the aquifer. And then there's the artesian zone. The artesian zone is where water will be able to come up to the surface. either through natural springs or through wells. So let's talk about our zones. In the drainage zone, any rainfall that runs off and does not go into the ground, does not permeate, will travel to the recharge zone. This is very important to protect as far as water quality. It's difficult, though, to convince the people who live there to protect it because that's not where they get their drinking water from. So let's go back to our map here. It rains out in Bandera. Some of that runoff goes into the Medina River, and as it gets carried through and goes through the recharge zone, it can recharge our aquifer. People who live in Bandera, though, do not get water from the Edwards Aquifer. Then there's the recharge zone. Water enters through faults, fractures, cracks, sinkholes, or just percolation, just simply soaking into the ground through the soil. This is where water enters. This is why on campus we've got those stormwater retention areas for grabbing all that water that would otherwise run off our parking lots and soak into the ground. And then there is the artesian zone. This is when the aquifer comes back up to the surface as springs. So all that water in the Edwards Aquifer is under a lot of pressure. And so that pressure pushes it up due to geography and the slope of some of the terrain. A lot of it curves around in the artesian zone. And so we've got a couple of springs. Some of the larger ones are the Comal Springs and the San Marcos Springs. It does not run as frequently due to humans pulling water out, but on the campus of the University of the Incarnate Word downtown, there is a spring that runs on occasion that was the original headwater or starting point of the San Antonio River. Now the water level of the aquifer tends to stay too low for there to be enough pressure to push water up out of that spring, but it's still there and protected on the campus. So our water's flowing in this direction again because of changes in elevation. And so here's some pictures of some of our springs. So there's Barton Springs out in Austin. During the summertime, you can go swimming there. Here's the San Marcos Springs. The San Marcos Springs are on the campus of Texas State University, also referred to as the Aquarina Springs. You can take a glass bottom boat tour. It's really neat to go and see. Water is super, super clear here. Then we also have, sort of at the other end near Del Rio, the San Felipe Springs. So how does the water come out and who uses it when it comes to our San Antonio, or when it comes to the Edwards Aquifer? And here's another picture of the Aquarina Springs in San Marcos. So about half the water comes out through springs to feed rivers. So this one here feeds the San Marcos River. The rest of it gets pumped out for a variety of uses. So there's municipal use, so that's all the people who live in San Antonio. Irrigation for croplands, for feeding animals, and then industrial uses. Now, the amount of water that gets pumped out of our aquifer does get protected, and that's actually a rather rare thing and an exception to the rule in Texas. Passed in 1993 and then put into full power, fully enacted in 1996. This is a state law, the Edwards Aquifer Authority Act, and it's a regulation to protect the water rights of permit holders and to preserve the aquifer for all, including humans and animals. That was a big thing with the all in it, that depend on it. Highly unusual. This is the Edwards Aquifer Authority Act is an exception to the rest of the state. Generally speaking, in Texas, if you have land, right, in Texas, if you have land and you can dig a well, you can pump out as much water as you want, because in Texas, in most cases, groundwater is governed by what's called the rule of capture. If you can dig a well and pump water out of the well, you can pump as much water out as you want and do whatever you want with it legally. Now, ethically, is that what you should be doing? I'll let you decide. But in most of Texas, you can do whatever you want. Back in the early 90s, let me flip back to this picture here. Over on the east side of San Antonio, there was a catfish farm here. And this gentleman, by his right of capture, and at the time it was perfectly legal for him to do this, he started pumping lots of water out of the Edwards Aquifer to fill the ponds for his catfish farms. He was this one person, this one catfish farm was pumping out as much water as the entire city of San Antonio at the time, back in the early 1990s. This got the attention of lots of the other Edwards Aquifer users because he was one person. Everybody else needs all that water, and why can he pull so much out? So due to that, it was brought to the attention, and because of the Endangered Species Act played a role here. Endangered Species Act is a federal law. All of the pumping from this catfish farm was leading to a decline in the aquifer. In our caves, there are some endangered species, and if that water dries up in the aquifer, then they don't have a place to live and they go extinct. And so we had the Edwards Aquifer Authority passed in order to preserve our land, our water for future generations. Again, this is an exception in Texas. Not much of Texas has their groundwater regulated. So when you're old enough to vote, one of the groups of representatives you'll vote for are board members for the Edwards Aquifer Authority. Those board members determine the regulations, monitor how much water is coming in and out of the aquifer. They look at how much water saws and other users can pump out. So in our Edwards Aquifer, some of the environmental impact comes with the endangered species. The moment there are 7 different endangered species, and one of which is threatened. We've got a variety of beetles, a fountain darter, which is this little bitty fish, a amphipod, little tiny crustacean thing, the San Marcos gambusia, the Texas blind salamander, and then a plant, Texas wild rice, and 1 threatened species. So all of these need protection under the Endangered Species Act. So if the water gets too low, we have to stop pumping to keep a habitat for these animals. In Texas, we do have lots of aquifers. There are 9 major aquifers and 21 minor. The Edwards Aquifer is the only one that is currently managed, and where the amount of pumping is regulated. On this map, the aquifer they show just the artesian zone. It's sort of this light blue area here. And then the largest one, the Ogadala, that's some of this orange area up top.